That's a lovely tune from John Williams, a classic movie, E.T. It's, for me, it's kind of cosmological as well, kind of brings the mind to the universe. As you can see here in this animation, actually, it does bring the idea of infinity and how immense the universe is expanding, as Edwin Hubble has proved to us back in 1920s, 1929, more precisely, as far as I remember. I mean, he should have won a Nobel Prize, at least two, I would say. But that's the universe, and I think it does give us an idea about fluids, something which is still kind of matter, but in a more less dense state. And some of these fluids we cannot even perceive within Earth, and never mind outside Earth. So the concept of dark matter, dark energy, is very fascinating for whoever is actually inclined to enjoy cosmology or astrophysics and astronomy, but cosmology more specifically, I would say. I just want to probably share quickly my excitement and interest about this paper, which I have read more specifically last year in depth, and I've been actually learning, because it's a very, very deep paper, especially if you're not a cosmologist by technical background, which is my case. I'm just a curious person, basically learning about the universe. So that's interesting to understand and kind of perceive, or maybe to imagine how massive, and this idea of this unknown dark phenomena, dark matter and dark energy, it can be a way to understand further and further our universe, and perhaps even our origin. And I think could be a path to that as well. And it's, again, it's all about fluids. It's all about these dynamics that we have over there that follow a very fast process, very fast velocities of all these particles. It's interesting. And then if we think about that, 95% of the whole universe, as we understand, as we know so far, is composed by these dark phenomena, which are dark energy and dark matter. The rest, 5%, is matter as we know. So it's interesting. I will just show here the numbers, which are, I said before, dark energy, 72%, just an estimation anyway by the scientists. And dark matter is 23%. So 95% of the whole universe is composed by dark energy and dark matter. There are plenty of nice books out there. That's a very simple one, very easy to read as well, very thin, but very didactic. Dark Matter and Dark Energy by Brian Clegg. Really interesting. So I recommend for first read anyway. And then matter is 5%. Matter, as we know, is 5%. As an observation there, and I mentioned before, and I'm working on a paper about that, is within this 5% of matter that we know, the most common state of matter is actually plasma, which is, again, is fluid, the idea of the very fluidic matter itself. And then it was the way we know now, but as this terminology, plasma, it's very well established. But to start with, it used to be called as radiant matter, and was discovered by Sir William Crookes, a well-known scientist that discovers so many other things, and also creates so many other things as well in many areas of our knowledge. So Sir William Crookes in the 19th century, he discovered radiant matter, which is plasma basically, and most of the state, the most common state of matter in the universe is actually plasma. It's very interesting. Again, fluids. Another observation as well, and I probably have mentioned before, Sir William Crookes in the 19th century, he helped indirectly to cosmology as we know now, because actually he was actually, with this concept of radiant matter that became plasma, this itself already justifies my statement here. But also he was helping, he contributed to our understanding, as we know now, about light and electrons as well in the background. So, and all these concepts, they were fundamental for the establishment of quantum physics or quantum mechanics, which gave the basis for cosmology as we know. So he actually helped indirectly cosmology, in my view, and he should be more recognized. So, as like Edwin Hubble, that he should have won a Nobel Prize for science. William Crookes as well, at least two, at least I would say so. But anyway, so progressing here, I just want to talk about the concept of dark phenomena and dark matter. I mean, dark phenomena is dark matter plus dark energy, and this concept of dark fluid has been introduced by Farnes, Dr. James Farnes, in 2018 in this great paper, scientific paper, which is publicly available actually. He unified the concept of dark matter and dark energy, calling dark fluid. And then, in my view as well, another potential hypothesis is that for the creation of this dark fluid, the most of the universe that we have here and everything else, we probably had another fluid which is more basic, perhaps cosmic fluid or universal fluid, we can call that. It could be something to be investigating further. In the same way as well, as a side note, when you think about Roger Penrose, even though the Big Bang theory is the most well-known and very solidified, Edwin Hubble justified pretty well with the expansion and all that, and it's the most realistic model that we have now to explain the origin of the universe. But I follow more. I follow Roger Penrose rationale, even though he didn't prove that. It's all hypothesis that there was something before the Big Bang. So it kind of makes sense if you think about, well, even for create this kind of bang before, there must something happen. There was something before. So these two kind of hypotheses to investigate further the beginning of the beginning, as you wish. There was something before the Big Bang. So I follow Roger Penrose hypothesis. He is a well-known cosmologist, a mathematician, philosopher. And then in that kind of parallel, I think to understand better the universe, of course, we need to understand better this unknown dark phenomena, dark matter and dark energy, dark fluid. Their natures are completely unknown still. And perhaps defining concepts that can help us even in a hypothetical kind of constructs, I would say. But